Hello, everyone. Mohammed is speaking here, and I am going to explain the code that we submitted as our project. Hopefully, you should have already seen the presentation of the project in terms of how it works, and now I'm going to explain a bit of internals and basically what is in the background. So this is our submission file. Readmes, obviously, I'm not going to talk about these. So we have makefile and shell C. Shell C is where all of the magic happens, and makefile is just there to basically install or compile the project on everybody's machine. So we can see here that the way it is compiling is basically just using GCC and a couple of flags, where it's basically at the end you should have the shell binary and how it's so basically when you run make, it's hitting all, and then it wants to build shell, and it has a definition for shell here, but it requires shell O as well for shell. So firstly it builds shell O from shell C, and since shell C is provided here in the directory you're doing it, so it can start from there. Now once it's built, it builds this, it builds shell O, and then it uses shell O to build this part, which is basically, so output of this file is shell, a binary, which you can then use to run the code, run the shell. Yeah, there is also clean command, which basically just removes object files, shell, and shell exit. This probably can be removed. And yeah, that's about it. So now let's move to shell C. So the file starts by importing plenty of libraries. Oh, so just a very important note. So as we already said in the description somewhere here in the README, so we used the shell that has been provided in one of our labs, and then we built upon that. So here I will explain everything, but I will definitely make a distinction which is basically just to show what is the code that we actually took from that shell that has been provided in the lab that we have been working with, and basically the code that is completely new, which we actually introduced. So as already said, these are the libraries. I'm not gonna spend any time on these. Libraries in C used for plenty of stuff which are used down here. Yeah, that's about it. So the next one here, we define some basically global constants. Here we have shell buffer size, which is 250 size, and shell max arguments, which is 8. These two basically define, so 256 is basically the maximum amount of characters you can have in one line of the basically in one command that you are executing in the shell. So if it's everything that you type over that, it will be trimmed. That's one thing. The other thing is shell maximum arguments, and maximum arguments here include both the binary name that you are executing. So that is limited to 8. So basically that means, and I think I have an example here. Yeah, so this is one of the examples. So for like here, you can see that I'm actually listing, and this is our shell. I'm basically listing plenty of shells, but I only see what, like 1, 2, 3, 4, 5. Yeah, only 5 of them. After that, I see none. So basically, you can see that. So this command will also be counted, which will be 6. This command will be counted, which will be 7. And basically, yeah, that's about it. It has to be less than 8, I think. So that's how this part works, and what is it used for? Why? Probably not needed, especially this one, because yeah, you can sometimes have commands bigger than that, but we left it as is. This part is the leftover from the code that has been provided in the lab, so we didn't touch that, but it can be increased. This one, both of these, probably nothing really will change, just maybe, I mean, the code should still work. 256 is probably enough of the limit for characters. Maybe only this one might be increased, but that's about it. Okay, shell will be using more memory, but that's trivial in this case really. Okay, so the next part is pass commands count. this is basically the amount of commands that we are storing for the history command that we needed to introduce, and this part is completely new, so we introduced this. So we are using if not defined, because there is a possibility, and this is the note that we added. So it is possible when you are compiling the code with make command to actually provide the flag as well. So you could literally do at compile time, you could say, pass commands count equals to, I don't know, 150 or whatever. And in that case, you would actually increase the history amount. We did not implement that, so that doesn't work in our case, but we did actually left room for improvement. So basically that can be done. And that's why you have this in if not defined part, where if that is not defined, basically if the flag is not provided, then the default value will be used, which is 9. Otherwise, the value that is provided when compiling the code will be used. And I will see how this is used in the code. So the next part is basically, so this part is related to parsing the input from the user. This is the built-in part, and this is literally, I mean, doing nothing. These are just basically flags that are used in the while in the for loop that we will see later on, just to differentiate what was the last character that we actually read in terms of input from the user. So the next two functions, I'm the child and I'm the parent, are obviously used for executing processes. I will come to these later, so skipping these now. And now we are coming to the main function, which is basically how our code works, right? So this is the entry point of our code and basically of your shell once you run it on your system. So PIDs here basically just used to store these variables, basically shell PID, like the PID of the original shell you are running, and PID from fork. I don't really remember what it has been. Yeah, so basically just used to getting the return value of the fork call, which is creating the child process. So, and yeah, that will be basically used for testing whether we are in the child process or in the parent process, because different return value is in place. Okay, I'll just skip these quickly because they are not super related. Just skim over them. All sorts of, so basically we'll run in background, obviously related to like flag for checking whether we used the flag to run the process in background or not, a parse state and all of that. Exec argument count, so basically how many arguments did the user provided in the shell, which includes, as I already said, binary binary we are executing. So all of this has been already provided. Buffer, so this is basically the character array where we are storing the input from the user itself. And as we said already, this is 256. It's a constant from the above, and here it is declared. Temp buffer, so this is, as we already said, this is something that we introduced here in the comment. This is used only for, basically, this is used by our history mechanism, and this is how we are using this temporary variable just to store it, and we will say later why. And so exec arguments, so basically this will be the array of arguments that we will create when parsing the command from the user. This is what we will use for execution as well. Shell PID here, so we are only getting the PID, that's it, like getting the PID of the process running. We will see later how it's used. Okay, so this part here, this is where we declared the sort of two-dimensional array, or basically array of strings, or yeah, in C. We will see, and basically this is how we store the command. So where we store the command. So we use it so that later on we can just access the commands that we run previously by accessing past commands array, which gives us like, so we can access commands like with just an index number like 0, 1, 2, or whatever. We will say later on where it's filled. So next to store and command count, so this is related again to our history mechanism. I'll come to that later. Illegal past command, again, just a flag that we are using for detecting whether the last command, it's not really illegal, but basically whether it's a command that we want to store or not in the history. And yeah, okay, so this is not related to history. This is just the character array where we are storing the a name of the current working directory we are in. As we can see, it's hard coded to 200 characters, probably enough. You don't want to store more than that. So okay, and this is the key part. So they basically, the shell works in a way that you have a while loop, which is constantly running, and this is again provided by the already existing shell from the lab. It's just constantly running and getting the input from the user. Once the input, so basically that's how actually it creates the illusion of, you know, some environment, while it's actually just, you know, printing the output, getting the input, and just going over and over, iterating and doing some actions on that output, on that input. So yeah, that's how it works. And yeah, so first thing that we do, because we want to, one of the tasks was basically to print, to prompt to display the current working directory. This is how we do it here. So get cvd, basically system call for getting current working directory. We are storing it in our variable for that. And yeah, this is how it's done, just getting the size of that variable. And we put that into if, because in case this is failed for some reason, we are basically just, you know, typing directory not read, and that's it. Otherwise we are basically printing what we get in that variable, and that's what actually is and this sign here is hard coded. So that's but basically creates the illusion of, you know, that dynamic change of the variables, and this is happening every time whenever you run the command. Okay, and that's basically everything related to current working directory. So store past. Okay, so this is the part where we are storing the command that we run to history. I will come to this later on the next iteration. So now I'm considering that we run the first command. And since, as you can see, this is at the beginning, we are literally just skipping this part because exec arg c is here 0 or not even existent. So basically, wow, what is going on? Okay, so this is totally skipped on the first run because there is no previous command to save because it's the first time you run the shell. And okay, this is the built-in, the already existent code. So this is just getting the value, getting the input from the user. And if it's success, if the input is for some reason equal to null, which might mean some kind of error, it just exits. Other than that, it basically just stores the input that user types into a buffer. And as we see already before, buffer is just an array where we are storing it. Okay, again, here we are storing running past commands. So basically, this is used for running past commands. Here, if we try to run the past command on the first run, probably it will go down here, but it will definitely break. I think it will break where, yeah. So here we have the command count, which we are keeping. So all of this has been introduced by us. This didn't exist before. We are just keeping the command that we count. So obviously, index will be index is built based on the character that is created after this exclamation mark. And if this is 1, for example, and since we already have command count and 0, this will not be true. So basically, we will just enter this part, and we will just say how many commands are available, which in the first run it will be 0, right? So nothing there, and it will basically just skip all of this part. So we come to the next part. So string copy, we'll come to that later. Still used for related to past commands. So this is what we introduced. And now we come to the parsing status. So here we go. So running command will just be, this is the built-in, not built-in, but provided already by the code. So running background is used for detecting whether the user added ampersand sign at the end of their command. If they did, this flag obviously will be true. If they didn't, it will be false. And basically, that's how we will know whether they want to run it in background or not, and we will act accordingly in the code later on. If they did, basically this will just be overwritten. So basically this sign, because we don't need it, will just be overwritten by the new line. And if this is 0 or false, basically like new line will be overwritten by new line. So nothing happening here. So this is the parser. Parser literally just goes character by character. This is already provided by the code, by the lab. So just going character by character, checking whether it's space or not. And once it finds space, it's basically storing the address of the first character. And then later on uses that to actually, so it saves all of that to exec argv array, and that exec argv array is basically what is used for executing all of the commands. So buffer is not used later on. This is just for the beginning. And yeah, that's if it's space, and if it's not space, it's basically it's just iterating over it. So if it's space, it's just iterating over it, but using this state and state space and state not non-space mechanism to basically detect when to store the address, so that it actually stores the address of each and every word, separate word of the whole line. So yeah, that's basically in a nutshell how it works. Not to go into details there because I'm already spending a lot of time. So yeah, a buffer here just used to terminate the last character because we are iterating over all of them. And okay, this is the critical part. So all of this here mentioned, and the parsing has been provided by the code, and this as well. If exec argument count is basically equal to 0, which means the user didn't provide any argument, we just run continue, which means we are running till the end of while loop and starting it again. So not executing any of the code that comes after. Okay, so the next thing is, again, terminating just the array with null value. Okay, this has also been provided by the code from the lab. So how this works is basically, so exit command is not, so it's built-in command in the shell. And how it's doing is basically just checking if the first or if the command is equal to exit. If it is, just printing exiting process and returns exit success. So return basically will return us from the main function and the code will stop. And exit success is basically just a constant, C constant for returning, you know, like a valid fine. So everything is okay, return success. Next option is basically if the user types CD, and also if the argument count is bigger than 1, because CD is 1, so it has to be bigger than 1. Otherwise, CD will not have anything to like execute into. So if that is the case, we are using change directory system call directly. This is already provided by the code, so just explaining it. The reason for doing that and not doing it through the child process is because we don't want to change the directory of the child process. Otherwise, the parent directory of the parent process will be intact. It will not be changed, and we want to change that one. So yeah, that's what we do. So this is in the if statement only because if it fails for some reason, if it does fail, for example, no directory or something like that, then we just print the error and we do nothing. And the last option, oh, sorry. So this is the history. This is what we introduced totally, completely. And I'll come to that later on. And this is basically the last option where we have two options. So what we are doing here is we are basically making a copy of this process using the fork call. And then we are checking, so this part of the code, so we know that, you know, parent will be created here. Oh, parent already exists. And child will be created here. And they will have parallel execution from this moment, literally, because we are creating a copy of the process. So what we are doing there is we are checking the code that, the return code that has been returned from fork. If it's less than 0, this is, so again, just iterating, this has been provided by the lab. If it's less than 0, fork failed, so nothing has been happening. We just print the error and just continue running again. Okay, so if it's 0, that means this part, because 0 will be returned to the child process, and non-zero positive integer will be returned to the parent process. So if it's 0, that means we are child, like child is looking at this code, and it is running the I'm the child command with basically the arguments that we have. And the I'm the parent, so in any other case, which basically means positive integer, because we already covered negative integers and 0, we are running the I'm the parent function, and we will explain that because it's at the top of the file. We skipped that. Yeah, and that's about it. So in case for some reason, so this is else, And let me just think about this quickly. Oh yeah, so it's this return. Oh yeah. So I think this return, yeah, this is the end of while loop. So this return is only run if if the code somehow exits the while loop. Usually that is not happening. So we just exit. Probably we exit way before this. But if we do, for some reason, we can exit from here as well. Okay, so going from the top, now let's talk about I'm the child and I'm the parent function. So I'm the child function has been already provided by the lab, but we did modify it. So we did add, so this is, and we mentioned that in the README, we hard coded the bin path. So basically our code supports running everything in bin path, everything in current directory, and without full path. Otherwise, user has to use the full path. So what we are using here is we are literally just creating another string to check for bin, and this is what we will concatenate somewhere here with the already provided command. So let's say that, for example, ls is the command that is provided. Ls is not the command usually you have in your directory where you're running the shell from. But it is located in bin ls. So basically we just concatenate that, and that's how we run it. So how is this working? Basically this is just checking whether that path exists. So if it does exist, it's just running it. So exactly we running the code, and that's it. Here checking the exit code. This is like a ternary operator for C. Basically same thing as if else statement. So if it's fine, it's running a zero exit status, so everything is okay. Otherwise, it's running negative status. That's it. That's in the case where actually it does find the binary that we want to execute. So in this case, for example, if we execute something that is located in our directory, and if we do find it, and we will find it in that case, it will run it. Otherwise, it moves and then it tries to find it in bin, right? So it concatenates that with the bin part and tries to access it. If it's there, then it will access it. So instead of, for example, in the case of ls is not here, but if you concatenate it, bin ls, okay, that will exist. So it will, access will return true. Oh no, okay. So access will return true, and then we will execute it. In every other case, so basically, so this part will cover full path and local commands. This part will cover path commands. This part, so this line probably, I've been looking at this early on, probably should be removed. So here we are actually saying that we did not find the command. So probably in that case, this doesn't make sense. Like we shouldn't be executing it, but okay, probably a leftover. So okay, yeah, that's how the I'm the child function works. So basically everything except for exit, history, and cd is being run in the child process, okay? And it's being run basically by the child process with execv system call, just running the executable that you provided. That's it, no big deal. And that's how all of the commands are actually executed. None of them are executed in the parent. Yeah, that's about it. So this is the sort of like a mix between what we already had on the lab and what we built for the lab and for this project. I'm the parent function, so this will be only called to the parent, as we said. This is only handling whether it will wait for the child to finish or not. So here, if it's running in background, so if it's running in background, we don't want to wait. Basically, we want to allow users to execute next command. So that's why it's immediately returning from this function, and then as we go, it will go to the while loop again, and user will be able to immediately execute the command, even though the underlying or child process is still running. Otherwise, if this flag is not provided, and we already explained how it's parsed, then we are actually going to wait for basically the child of this parent to finish, and we are storing the return value in this child return variable. And yeah, once the process returns, we are getting the error code in case there is one, basically. And yeah, that's about it. Then we are checking the code. If it's 0, that's not an error, obviously. Maybe not the best way to name the variable. Then so if it's 0, this part will not be executed. So we just finish. So we waited for it. Everything is fine. We will give the user the prompt again. Otherwise, if it did fail, which means the exit code is non-zero, then in that case we are printing the error just to make sure that user knows that the child failed, even though it's run in the background. And in that case, we are still providing the prompt, obviously. Okay, so that was one command. So let's say that we executed the ls command. Now I just want to talk about how we track all of these past commands. So if we go from the beginning, so we said we are storing the past commands here. But what will happen here? Yeah, so this is how we store the command. So exec arg c, as we said, in the first run, it is undefined, right? So we will not go in this case. But in the second run, by basically the second prompt, which means we already executed one command, then we do actually have this count here. So we are already in, coming in. Illegal pass command. So this is set along the way. We will come to that later on. This is set along the way. So if it is not illegal pass, if it is not illegal command. So basically this mainly means if it is not the command that we want to skip. So if it is the command that we want to store, then we will execute this part. Otherwise, we just set this part to 0, just to reset the variable, and we continue the code as it runs. So how we are storing the variable? Let's say that it was legal, so not illegal. So basically, we are just copying the temp buffer, and we already, as you know, we already copied the buffer, real buffer, to basically temp buffer. So we are literally just storing the whole buffer. That's how we are doing it. So literally we are storing the whole input of the user before it's even parsed in the array. So that way we managed to reuse all of the code that we still have, and all of including the parsing and all of that, by just changing the buffer, right? So if it is real command, we will parse the buffer. If it is a special command, which is like starting with exclamation mark, we will see that later. We will not parse the buffer as usually, but we will firstly copy the past command to that buffer, which will, as we can see here, that will just be the original buffer at the time, and then we will parse it as we usually do. So here, basically, command count means how many commands are actually stored. So that's why we actually calculate this. And yeah, so next to store is basically, so how we are storing the variables. We are storing them in an array, but we are going in circles, right? So as we can see here, we are storing 9 variables. So what we do here, and as already said in the demonstration, this probably could work better. Maybe it's not totally stable until 9 should be totally stable. This is why. So how we are doing it? We are literally writing 9 commands, and we have 9 places in our array, right, in here. And once we fill out all of these, we go from the beginning, and this is why we have this next to store. So if that next to store is basically pointing us to the fact that we already filled out all of the items in the array, we actually want to store, to reuse the array, to start storing the commands from the beginning, right? So, and that's why we are using this and using the next to store, just to set it here. And this will be used then in next iteration the same way that it has been used here, where we stored that command in using the next to store one. Otherwise, if we did not use the whole array, say that, I don't know, we are at command 5, then we will just increment that and we will store 6 one, right? The next one, if we stored in place 5 in this iteration. And that's how we are doing it. So we are constantly going into circles and overwriting basically the oldest command existing if we already used all the array, all the size of 9. If we didn't, then obviously we have free spaces, and that's how we do. Otherwise, yeah, this already explained, and let's move on. Okay, this is explained, this is provided, and this is our code again. So, okay, so how this works is, so firstly, we are checking whether the first item in the buffer that use in the user input is exclamation mark, which will actually point us that user wants to use the special syntax for running past commands. So the next check is related to minus. We didn't implement this. So in this case, as you can see, we consider minus as being a legal command because we don't want to store like, question mark minus and that's it, or anything, or the whole buffer. And we just continue. Okay, so we are skipping saving that in the next loop, but also we do nothing there. If this has been implemented, we would already probably have the code here, some like maybe a bit complex math to actually get, not complex, but basically just to get the command, but not with the real number, but basically relative to the current command. Shouldn't be too difficult to implement, but yeah, we didn't do it. Okay, so if that's not the case, so if the second item is not minus, that means user probably entered number, right? So, and here we are limiting this to basically commands from 1 to 9. If you execute 10, that will mean that the second item in your array, second character, is not new line. It'll probably be 0. And that in that case, we go to this part where we say it's not possible to use with 2-digit numbers because right now we only support 9, right? So this is one of the limitations, right? And we again set the illegal pass command 1 so that we do not store that command because it's not executed, it's not successful really, and no need to store that. So yeah, and that's it. Once we have figured out all of that, index will basically just this line basically just converts the number that user put in, but as we already know, this is a character. This is not still a number. So just subtracting 0 from that, it actually turns it to an integer, to a real like value of the character of that, yeah, of that number. And then we are checking if the index is actually bigger than the total count, total number of commands that we already executed, because it doesn't make sense to ask the shell to execute, I don't know, 6th command if you executed only 3. And this is what we do here. We check it again, as telling you, you can't do that because you don't have that many commands yet in the history, and just basically setting the illegal command flag. And then later on, so basically going further, if that's okay as well. So basically, if the command is less, now this is a bit interesting. So what we do here, I'll just explain it quickly. What we do here is we make sure that, because we know, as we said, since we are going in circles, since we are storing all of the commands in circles, and since we are overriding, basically in this case, if we have 9 commands, we are overwriting all of the commands that are, executed 9 or more commands before, right? So if we didn't have this part, we would probably be executing, and all of these values should be available in the array, but that will not correspond to the command actually executed in the shell. Since we have this check, then we already make sure that we are checking 9 commands before now, no matter what is their location in the array, but basically the real ones, not the 9 before. So hopefully this is clear. And that's why we have this part. And if that's the case, we just continue, set the illegal pass command, no executing there, because you literally don't know what you will execute here at this moment. And if all of the checks have been actually passed, what we do is, okay, we index or decrease index only for the purpose of the array. And we are basically, oh yeah, so this part here ensures again that we, like cycle back and to the range from 0 to 9. Okay, so if let's say that if this is 13, and if you want to execute last command, which will here be, I don't know, 9, and that should work, I think. If you say 13, and if you just say 13 minus 1, that will be 12, and we don't even have 12 places in the array, right? So we need to continue decreasing by the full size of the array until we actually are within the range of the array. And if we are, that will guarantee that we are actually hitting the command that user wanted. Hopefully this is clear. Once we make sure of that, we are literally just storing oh yeah, so what we are doing, we are summoning the command that has been stored in our array to the buffer. This is what I have been referring to, because as we said above, we are actually storing the whole buffer. So since that's the case, we can just pull it up from the array, and that's it. Again, we are here printing it just to show what the command will be executed. That's it. And that's whole history how it works. String copy, again, just used for temp buffer, as explained before. Yeah, just used. So this is basically used not to mess with the current buffer. And the reason for this is because we are constantly playing with temp buffer, not to change the buffer. And basically, we want to change it not only to use the buffer, because this is the variable that has been used in the usual code. Otherwise, we would need to introduce, I don't know, completely parallel set of or whatever path in the code or something like that. But this way, we just put it back to buffer, and yeah, it works. Because we here somewhere, yeah, that's how it works. And yeah, that should be fine. So that's it. So we did talk about this part. I think we covered everything. The last thing that I want to mention, which skipped, is basically the history command. Again, this is a built-in command. Where is it? Okay, it's up. Okay, here we go. So this is CD. Okay, yeah. So this is again just another if condition before we try to execute the child. If user enters history, what we literally just do here, we just iterate through our array where we store all of the commands, we print them out together with the number of the command, and yeah, just the command. That's it. Another thing that I want to mention here is basically when we are storing the command, just to show that as well, just to refer to this cycling. Yeah, so here we go. Yeah, I actually think I actually mentioned it already. So as we said, because next to store command is just incremented, and if we come to the moment where actually next to the store command is, let's say that you executed 9 commands, and next to store command, sorry, 8 commands, and we just stored, let's say, your 8th command. So the next command that we are going to store will be 9th command in the next run of the while loop. Next store here, sorry, next to store, yeah, next to store has been 9. Okay, that would be the scenario that we will cover. So next to store has been 9, which means you actually covered stored your 9th command, and your array is already full, so you cannot store the 10th command in this particular case, how we set this up. And now this is what we are doing. If the next to store is 10 in this case, which will basically pass commands count a -1, and this is the set to 9, I think. Yeah, there we go. So if that's the case, that means we have no more places in our array, which means we want to start from the beginning. And this is, I really like this. So we actually set it to 0, and that's how we cycle back. Otherwise, if that's not the case, it's safe to just increase the value. And yeah, so yeah, sorry for taking maybe a bit more time than needed. But yeah, I think we explained all of it. As already said, part of the code has been used from the lab. We really didn't want to reinvent the wheel, because we already have seen that code. We already talked about it in the lab, and probably what we would come up with would be more or less the same. So as you can see, we really do understand what is it, how is it working, and why is it doing all of this. So maybe we would have different name of variables, but I don't think it's worth doing that because it's already available. And yeah, and all of the things that we introduced in addition to that, we basically explained here. Yeah, just to note again, so this part here about adding the path in bin, so this is not provided in the lab, but we did this as an exercise from the lab, but this is still our code. So this is completely something that we introduced, just not for the project. We introduced it before because we already played with that, and we just just reused it here. So yeah, that should work. Yeah, so possible improvements already mentioned. Probably path could be configured so that we are maybe introducing like a config file for the whole shell, so that you can literally store all of the variables that we have here, like constants, and even this like whole set of paths that you want to support, as the same way that the current shells that we use are doing it. But yeah, we didn't do that, but definitely could be done. Cool. Thank you for listening, and let me stop recording. Hopefully I won't lose anything. Yeah, that should be it. Enjoy your morning, afternoon, evening.
Okay, so hi, my name is Maida. So today we will demonstrate our project. I will introduce you to our shell. So by writing this command, we are joining into our shell. So here we can write some commands that our project supports, like ls, which lists all the files and directories. And also we can write the command min, which shows that we are in a current working directory. Here we can list, uh, we can also join into ls min command. So here we can see all the commands that our project supports and that can be used without full path. Also, the other commands are working, but we must the full path for that. So yeah, that's it.
Um, so Neja speaking at the moment. I'll explain our functionality to of our prompt to show the current directory we are in. So we see we get at first directory we started from. So we are able to see that like this. If we type pvd, we can exit our current directory to go back. So you see now we are not in opteron shell directory. We can get back there if we just type run as help. Uh, so we see we entered again in opteron shell directory. We also, to prove this, could make a new one. Like this. So we could enter this one here. So we see now we are in ABC directory that we weren't before, and we can also exit, and we again took step back. And that would be it for this functionality.
Okay, so now it's my turn. Hello, my name is Omar. Omar is presenting. Just let me access my virtual machine. Okay, so here we are. So in our shell, my task is to show you the history functionality of our shell. So we want to print out all the commands that we previously used. We managed to make this happen with 9 commands, exactly 9 commands. Above 9 commands, it is also possible that it works, but we cannot guarantee above 9 commands because it is a little bit, shaky. But so let's demonstrate this with the 9 commands. Let's use echo because it's the simplest one, just for printing. Echo 1, 2, 3, 4, 5, 6, 7, 8, 9. Echo 9. Okay, so now let's say we type these commands and we want to access them. We just type in history and these commands will be printed. So this is the functionality of our shell of the command history. And let's say the user wishes to access a command, not all 9 commands, but he wants to access a specific command. So he can just type exclamation mark and then whichever command he wishes to access. So let's say command 6 and enter. And so you can see that first here it is printed out which command we accessed and then what the command does or whatever the command is. And that would be it on my behalf. And that is the functionality of our history. Bye.
You can stop the recording as well.
Okay, so hi, my name is Maida. So today we will demonstrate our project. I will introduce you to our shell. So by writing this command, we are drawing into our shell. So here we can write some commands that our project supports, like ls, which lists all the files and directories, and also we can write the command min, which shows that we are in a current working directory. Here we can list, we can also join into ls min command. So here we can see all the commands that our project supports and that can be used without full path. Also, the other commands are working, but we must the full path for that. So yeah, that's it.
Um, so Neja speaking at the moment. I'll explain our functionality to of our prompt to show the current directory we are in. So we see we get at first directory we started from. So we are able to see that like this. If we type pvd, we can exit our current directory to go back. So you see now we are not in opteron shell directory. We can get back there if we just type road as help. So we see we entered again in opteron shell directory. We also, to prove this, could make a new one. Like this. So we could enter this one here. So we see now we are in ABC directory that we weren't before, and we can also exit, and we again took step back. And that would be it for this functionality.
Okay, so now it's my turn. Hello, my name is Omar. Omar is presenting. Just let me access my virtual machine. Okay, so here we are. So in our shell, my task is to show you the history functionality of our shell. So we want to print out all the commands that we previously used. We managed to make this happen with 9 commands, exactly 9 commands. Above 9 commands, it is also possible that it works, but we cannot guarantee above 9 commands because it is a little bit, shaky. But so let's demonstrate this with the 9 commands. Let's use echo because it's the simplest one, just for printing. Echo 1, 2, 3, 4, 5, 6, 7, 8, 9. Echo 9. Okay, so now let's say we type these commands and we want to access them. We just type in history and these commands will be printed. So this is the functionality of our shell of the command history. And let's say the user wishes to access a command, not all 9 commands, but he wants to access a specific command. So he can just type exclamation mark and then whichever command he wishes to access. So let's say command 6 and enter. And so you can see that first here it is printed out which command we accessed and then what the command does or whatever the command is. And that would be it on my behalf. And that is the functionality of our history. Bye.
You can stop the recording as well. Whenever you did listen to this.